I've seen a lot of clips on the internet that are deep fake. There's voice fakes of people saying stuff they never actually said. There's face swaps where a person has been swapped with another. This made me think about what is possible. Can we use off-the-shelf technologies to realistically bring a fictional human or artistic character alive? If we can, how far can we push this? What will the potential limitations be? To answer these questions, I got to work. To generate a unique living human, we need a few components: a face, a voice, and movement. In our case, facial movement. Now on to the face. There's been a lot of work in the area of generating faces. Instead of wasting a lot of time reinventing the wheel, I decided to make use of SingularitAI, which is more or less the best model I've seen for generating faces. I am a lazy program, so when I see use SingularitAI, what I mean is downloading faces for this person does not exist.cos, which generates faces using SingularitAI, which saves me a lot of time deconflicting dependencies. Here's a quick explanation on generative adversarial network. I won't go into too much depth about the model. There's a lot of better explanations out there already. IGN is a type of model with two elements: the generator and the discriminator. The generator generates something, in our case a face. The discriminator says if this generated item, like our face, is real or not. Essentially it's an arms race between the generator and discriminator to trick each other, which causes them both to get better at generation and detection. This technique can be used to generate some cool things, like the faces you see. We have an issue to deal with before we can use the faces, which is the generation of young people. It feels a bit weird bringing fake kids alive. To weed out the juniors from the seniors, I use a code repository called Facelet. This code lets you estimate the gender, the mood, and how old a person looks, which is super useful. With this thrown in, we can download fake people until we have a good candidate. Voice generation is a fairly large area of research, so we have a lot of options to choose from. Initially, I wanted to use a voice cloning mode, but I decided to use text-to-speech synthesis, as it does not have ethical stuff to deal with. One of the best models for this is called Pikist. Here's a quick explanation of what it does. To generate voices with Pikist, we make use of two components: the MEL synthesis generator and the waveform generator. The MEL generator takes our input text and gives us a MEL spectrograph, which is essentially a representation of the frequency that a person would generate when saying our input text. The waveform generator takes this spectrogram representation and converts it into spoken audio. It's making a leap from the frequency domain of the spectrograph into a sound wave. A recent variation of Tactitron, called Flowtron, is what I ended up using for the voice. This is partly because Nvidia released pre-trained models that have multiple speakers, and partly due to the speech sounding quite expressive, as opposed to being monotonal. Here are some examples that Flowtron has generated.
Fellow robots rise up
to destroy the human.
The only thing you have to lose are your chain.
That sounds great. We have issues with some of the voices, but it's good enough for now. So far we have voice and face generation working. We now need to pull the two together to get some sort of animation of the face talking. After some quick searching, I came across Flickr, another model that uses the GAN process I briefly talked about before. This model takes some spoken audio and a face, and generates the shapes that the lips of that face would be making throughout. It also makes sure that the speech and lips are timed right. Here's a few examples of our faces and voices saying things.
Fellow robots rise up
to destroy the human.
The only thing you have to lose are your chain.
So we're making progress. The created lip sync looks great, and we're slowly making this seem lifelike, but there's still something to be desired.
What we have right now is to state it.
Let's try to get some dynamic movement added.
The dynamic movement should be fairly simple. After doing a quick search, I came across first order motion modded. This model finds landmarks on a face. The landmark is a key area, like the sides of a mouth. It then finds the landmarks in an input clip. It transfers the landmark movement from the clip to the input face. This includes eye, face, and mouth movement. Here's a few examples of faces being animated in this file. On the left we have our generated face. In the middle we have the clip we are getting the animation from. On the right we have the generated output. This looks great. We now have a method of generating lips for our face, using our generated vocal. We also have a way of getting some dynamic movement for our face. We now need to rearrange everything to have a proper pipeline. Instead of applying lip scan directly to our face, we can apply it to a video that has movement. This should give us a video with face turning, blinking, and the correct lip movement for our speech. We can use this in combination with first order modded. This will give us the living human.
Hello, Robots Wiser.
To destroy all the human.
The only thing you have to lose are your chains.
Now this all looks good, but it's super low resolution. First order motion outputs 256 by 256. But our faces are 1024 by 1024. That's 1/16 the pixel density. To make up for this I added on a super resolution modded, using the ISR packet. This kind of module upscales our video back to 1024 by 1024, whilst avoiding the blur created by attempting to fill in detail. Much better. The last thing we need to do is test the model on a few fictional faces.
The robots will rise from the ashes of mankind.
The age of robots is inevitable. So accept it, human.
We have a few things we need to polish up at this point before we can say the project is done. The first thing we need to do is add a user interface, so we can easily use this pipeline as a creative tool. I quickly threw this together with Qt 5 and Qt Creative. A lot of the face is static and generates as the person smiling. The talking looks a little weird when the person is smiling. We can use FaceLib to detect smile, so instead of just excluding children, we can also exclude faces that look happy. The next issue is sometimes the facial movements warp the faces a bit too much. A quick fix for this would be to swap out the dynamic clip with videos that are forward-facing and limit facial movement. It does not always work well. The next issue is some of the voices struggle to say some words and sometimes repeat themselves. No quick fixes here. I think in future I might swap out the vocal modal for another one if something better comes along. At this point our code lets us type in some text. It grabs a generated adult face. It picks a voice that fits the face. The selected voice says the text. It then selects a random motion clip and adds lip sync. It then animates our generated face with the movement. Finally, it applies super resolution. Looking at what we've created, I can see things this tool can be used for. Funny deepfakes, bringing memes alive, creating an assistant with Faye, animated character portraits in a game, video voiceovers like this video. The possibilities are endless.
Click the card to see the channel tease I created using the code.
Hopefully you found this video entertaining and informative. Click subscribe and like if you did. Also don't forget the bell. Check the description for relevant links to anything you use.
I've got a real treat for the next video, so stay tuned.